Okay, in this tutorial I'm going to build on the skill of describing patterns of change as shown by a graph. And we're also going to maybe think about seeing if we can maybe see if there's some kind of relationship between the two different factors that are shown in this graph up here. Okay, so the first thing that you will have wanted to do is actually read this here. Okay, and the key idea that we're investigating is trying to establish whether there is some kind of link between the changing temperature of the planet, and that is shown with the red line. You can see it there going up and down across time, and whether it is linked with changes in the actual temperature, in the amount of carbon dioxide. You can see that that's going up and down, okay, as well. And one of the things that climate scientists have started to recognize is that there is a link with carbon dioxide, or CO2, and the planet's overall temperature. And luckily, because of ice cores that we find in Antarctica, we are able to actually calculate both of these things for our planet, going back an awful long time. You can see here on the x-axis of the graph, we can go back 400,000 years to find out what the planetary temperature was and how much carbon dioxide was in the atmosphere. And one more thing before we have a look at the three questions that you're going to be asked to answer with this task is that, why think about carbon dioxide and what's that got to do with planetary temperature? Well, what we have discovered, or what climate scientists discovered, and what you're going to be building on in other lessons later on in this topic, is that carbon dioxide is a greenhouse gas, and it plays a major role in influencing how hot or cold our planet's climate is. Okay, and what we've been finding is that the more of the greenhouse gas of carbon dioxide, as well as other greenhouse gases that are present in the sky, in our atmosphere, the higher the temperature is. And this leads us to this idea of global warming, that at the moment, as we saw in the last tutorial, that global temperatures are 1 degree warmer than they were in 1980, then our planet is warming. We are experiencing global warming. Right, let's get on with the key questions that we are investigating today. So what is the pattern of change? Now, in the last tutorial, you were shown how to do that. What is the pattern of change in global temperatures? Now, we're dealing with a different x-axis here. We're dealing with 400,000 years, okay? We're not dealing with 140. So let's just explore this. The red line, by the way, is the one we need to be looking at the moment, because that is the global temperature line. And we need to be using the left-hand axis because that's what's being used to read changes. We'll look at task 2 in a second, which uses the blue line and the right-hand axis. Okay, so let's just explore this first question. Well, as I said in the last tutorial, you need to start with where it was. So at the beginning, 400,000 years ago, planetary temperatures were on average 2 degrees warmer than the long-term global average, 400,000 years ago. Okay, what would we then say? Well, that they then actually dropped to about -8 degrees, lower than the long-term average, over a period of roughly 100,000 years. So from there to there is about 100,000 years. So that would be the first kind of statement. 400,000 years ago, they started at 2 degrees above the global average, but then they dropped to -8 degrees below the global average for about a 100,000 year period. Now, that, by the way, is what we call an ice age. And that's kind of what we're seeing in this graph. Around about 300,000 years ago, and I say roundabout or roughly because you don't need to be precise with these kind of timescales, it then rose back to being above 2 degrees for a very short period of time, and we're looking right there. Then another 100,000 years go by, and it drops back down to about -8, before rising again about 250,000 years ago, back up to about 2. It then spends about another more than 100,000 years this time, so we're going from here to here, at about that between -6 and -8, before then, for a short period of time, rising again at about 130,000 years ago. So if we just draw kind of an imaginary line down here, we can see that's about 130,000 years ago, back up to 2 degrees. And then since that point, from about 130,000 years ago, the temperature dropped to about -6 to -8 again. So we're looking at this period here. Across all that whole time, and only in the very recent period of time, we're talking about the last 100 years actually, has the global temperatures risen back up to being about 1 degree warmer. Okay? And that's happened very recently. So that is how I would describe this first question. Once again, let's just review that. What is the key? I have given dates. I have given amounts using my axis. I've picked out the fact that there are key points across the last 400,000 years where the temperature's gone above that 0 4 times before the current time today. The rest of the time it's been in Ice Age for roughly 100 or 100,000 years and more, when the temperature's been as cold as -8 below that long-term average. Okay, let's have a look at task 2. What's the pattern of CO2? Well, think about it. The pattern of CO2 is almost exactly the same as the pattern of global temperatures. You could use my same descriptive statements. The only difference when you do this is rather than use this axis, you must use this one. And this brings me to the second thing. Instead of talking about degrees centigrade, you need to be talking about what's called ppm, or parts per million. And so, for example, let me just show you what you would be doing. So the amount of CO2 in the atmosphere starts at roughly, and this is where you have to draw a little imaginary line across, around about 280 ppm, parts per million. What that means is there's 280 carbon dioxide molecules for every million other gases in the atmosphere. Okay, so that's what actually how it's measured. How many little molecules of carbon dioxide is there amongst all the other things that you find in the atmosphere? So 400,000 years ago, we're at that. It then drops to around about 180 at about 350,000 years ago. It then rises back up to about 280. And then all I've got to do is just work my way along, giving dates. So around about 250,000 years ago, it drops back down to 180. It then rises a bit less to about 260, dropping again for a long period of time to about 140,000 years ago, where it then rises to one of its peaks. It's about as high as we've ever seen it. I'm just going to show you that here. So there, and that was about 130,000 years ago. It gets about to 280. It then drops steadily down to about maybe 2,000 years ago, where it's around about 190 to 200 parts per million. And then, and this is the only bit that you do a bit differently, there is then a rapid increase from about 1,000 years ago up to 400, which is, and this is a kind of key statement, which is far higher than it's ever been over the previous 400,000 years. Okay, so that is number 2. And finally, task 3 is what's the relationship between the changes in temperature and the changes in CO2? Give evidence. So you're going to want to talk about how the fact that as one falls, the other falls, and as one rises, the other rises. What you're going to want to say to give evidence is you're going to have to pick out maybe 2 things from the graph that shows when it was rising, both of them rose. So you could say, for example, about 130,000 years ago, the carbon dioxide rose to 280 parts per million, and the temperature rose to about 4 degrees above the global average. Likewise, it fell. We can say it fell to a low here. Global temperatures fell to -6 degrees around about 350,000 years ago, and CO2 was also falling to one of its lowest levels of about 180 parts per million. So that is giving evidence from a graph to support the fact that you will notice both of these lines go down and then up at the same time as each other, roughly. If you think, and this is for those of you that really want to add another little sentence, is there any time where there's maybe a bit of a difference? Is there any time you can spot where maybe the carbon dioxide rises but the temperature doesn't rise or doesn't do what the carbon dioxide was doing? Or like the other way around, does the carbon dioxide change and the temperature doesn't? So if you think you can spot something on the graph where they're not quite rising and falling together, then make that comment and give the dates to prove that's the case.